Hello everyone and welcome to this tutorial. Today we're going to be looking at fractions. Now what is a fraction? Well, similar to a decimal, a fraction is just a way of expressing part of a whole number. So we already know decimals and we already know that we can express parts of whole numbers as decimals. For example, 1 divided by 2 is equal to 0.5. But what about 1 divided by 3? Well, we could use the bust up method and we can go through and divide these together, or we could just plug it in on a calculator and you'd get this 0.333333 recurring. This is one of those recurring decimals that we covered in the last lesson. This is really inconvenient to write because we could never write out this whole number. It would just go on forever and ever and ever. We need a better way of expressing non-whole numbers. And fractions are that better way. For me, the easiest way to understand a fraction is to visualize it. So for example, if we've got a really tasty pie like we have here, and we split this between 3 people, we can draw on the sides of the slice that we'd each get, and it would look something like this. So 1 pie divided by 3 people. We can generalize this and we can say that if we have any two random numbers, a and b, and we divide them by each other, so a divided by b, that is equal to the fraction a over b. The advantage of using fractions is that they're exact and they should always be used in preference to decimals. For example, when we were doing 1 divided by 3, expressing this as a decimal gives us 0.333333 recurring. So eventually we'd have to round that answer to a certain number of decimal places, and when we do that, we remove some of the accuracy of the answer. However, we can really easily express 1 divided by 3 as a fraction as just 1 over 3. So because of this, we should always use fractions where we can. Unless the exam tells you to use decimals in your answer, always give your answer as fraction. Just a bit of terminology here. Whenever we have a fraction, the number on the top is the numerator and the number on the bottom is the denominator. The way I remember this is by thinking D for down, D for denominator, D is the bottom of the fraction. So in this case, A would be the numerator and B would be the denominator. Okay, hopefully that all made sense. Now we can move on to looking at how we simplify fractions. The best way again to explain this is by using an example. Let's do the division 1 divided by 4. We know from the previous rule that we were looking at that this is just equal to 1 over 4. And then let's also do 2 divided by 8. We can write 2 divided by 8 as a fraction, and that would just be 2 over 8. Now let's visualize both of these fractions and draw them out how we had on the other screen with our tasty pies. Well, first of all, 1 divided by 4 is just 1 pie divided by 4 people. So one slice would be this big. 2 divided by 8 is 2 pies, but this time we're dividing them by 8 people. So we need 4 slices in each pie. So 4 slices here and 4 slices here. You can see that these 2 slices are exactly the same size. This tells us that 1 over 4 and 2 over 8 must be equal to each other. This is because of a special fractions rule which says that we can multiply/divide the numerator by whatever number we want as long as we do the same to the denominator. When we do this, the fractions that we get will all be equal. For example, we have 2 over 8, and if we multiply the numerator and the denominator by 2, we'll get 4 over 16. Then we can do the same again, multiply the numerator and the denominator by 2, and we'll get 8 over 32. All of these 3 fractions will be equal to each other. If you don't believe it, then you can go and visualize them, think of pies or cakes or anything like that, and you'll see that the slices that you get in each of these 3 cases are all equal. So you can see now that we can write any fraction in a load of different ways. We can write 1 over 4 as 1 over 4, or we could write it as 2 over 8, 4 over 16, 8 over 32, and so on and so on and so on. However, to simplify a fraction, you make sure that the numerator and denominator are as small as possible as long as they're still whole numbers. For example, the simplest form of 2 over 8 is 1 over 4, because the numerator here is 1, it can't get any smaller than that without being a decimal. We'll do some examples now. Let's try and write 288 over 14 in its simplest form. For this example, I'm going to walk you through a really simple 3-step process that will let you simplify any fraction with ease. For step 1, we just have to express the numerator and the denominator in terms of their prime factors. If that doesn't make any sense to you, just go and watch the lesson on prime numbers and you'll see how we do it. It's a really, really simple process. When we do this for our example fraction, we're going to get 2 times 2 times 2 times 2 times 2 times 3 times 3 over 7 times 2. So this, remember, is just equal to 288 over 14. Then all we have to do is circle the prime numbers that appear on the top and the bottom of the fraction. So we have a 2 here and a 2 here. Then we can just check the top. We don't have any 7s, so that is it. And you can see now that these two numbers are just going to cancel out. So all that's left for our final step is just to remove the circled numbers from our fraction. So you'll see here that we just get rid of the 2 on the top and the 2 on the bottom to be left with 2 times 2 times 2 times 2 times 3 times 3 over 7, which is just equal to 144 over 7. And this is the simplest way of writing 288 over 14. Just as a little extra side point here, in step 2, when we're circling prime numbers, the number of numbers we circle on the top has to be equal to the number of numbers that we circle on the bottom. So for every 2 that we circle on the bottom, we can only circle 1 2 on the top. If there were 2 2s on the bottom, we could have circled another one of these 2s on the top. So just make sure we're not making any mistakes there. And as a little check at the end of step 2, you can make sure that the number of numbers that you've circled on the top is equal to the number of numbers that we've circled on the bottom. I hope that this lesson has been helpful. Thank you so much for watching.